In today's lesson, we're going to continue looking at recurring decimals. Last lesson, we noticed that some of the fractions gave us recurring decimals in our conversions. You'll also need to be able to convert these recurring decimals back into fractions. The best way to demonstrate this is by looking at some examples. In this first example, it asked me to write 0.5 recurring as a fraction. I'm going to start off by writing out exactly what this means, so I can say that x is going to be equal to 0.5555 and so on. Next, I want to think of an equivalent equation to this which has the 5 as the recurring part of the answer. So for instance, if I times this whole thing by 10, I could also say that 10x is going to be equal to 5.5555 and so on. The important part of this is that the values that come after the decimal place have the same recurring value. If I was now to find the difference between these two equations, I know that all of the recurring 5s would simply cancel each other out, and all I'd be left with is 5 take away 0, which is 5. I also know that 10x take away x would give me 9x, so 9x is equal to 5. The last thing I can do is solve this equation and leave my answer as a fraction. So I divide both sides by 9, and that would give me x is equal to 5 over 9. So that would be 0.5 recurring written as a fraction. Let's have a look at a slightly harder example. This time we're asked to write 0.407 recurring as a fraction. As before, I can start off by writing out exactly what this means. So I'm going to say that x is equal to 0.407407 and so on. This time, to get an equivalent equation that has the same recurring part in the decimal, I'm going to have to multiply by 1000. This would give me 1000x being equal to 407.407407 and so on. What you'll notice again is that if we were to subtract these, the recurring parts are all lined up, so they just cancel each other out again. So, doing that subtraction, all of the recurring parts will cancel out, and we get 407 subtract 0. That's going to give me 407. I know that 1000x take away x would be 999x, and solving the equation that we've got here by dividing both sides by 999 tells me that x is equal to 407 over 999. Usually this answer will suffice, but if you are asked to simplify it, you could in fact divide the top and bottom by 37 to cancel it down. This would give you a simplified answer of 11 over 27. That therefore means that 0.407 recurring as a fraction would be 11 over 27. Now, with those first two examples, you might spot a pattern between what's happening with the denominator and the numerator that you might think is a shortcut. If, however, we have a fixed number and then a recurring part of the decimal afterwards, that doesn't necessarily work. That is why this whole process is important to help us convert these more difficult recurring decimals into fractions as well. So, in this next example, I'm asked to write 0.82 recurring as a fraction. That's a fixed 8 and a recurring 2. I can start off as I did before by writing out exactly what this means. So x is equal to 0.8222 and so on. This time, because it isn't just the recurring part that comes after my decimal place, I'm going to have to write down two equivalent equations that I can use. First of all, if I multiply by 10, I can say that 10x would equal 8.2222 and so on. If I multiply the original equation by 100, I also get 100x is equal to 82.2222 and so on. Notice how the recurring parts of both of these two equations are the same, and therefore if I was to subtract them, it would all get cancelled out. So if we do this, all of the recurring 2's would cancel out, and I get 82 subtract 8. That gives me 74. I also know that 100x take away 10x would give me 90x. So 90x is equal to 74. I can now solve this equation by dividing both sides by 90. That therefore gives me x is equal to 74 over 90. As before, this fraction can be simplified, so if I divide the top and bottom by 2, I can say that's the same as 37 over 45. That means that 0.82 recurring, that's a fixed 8 and a recurring 2, can be written as 37 over 45 as a fraction. So, one final example to demonstrate this is writing 0.50031 recurring as a fraction. That's a fixed 500 at the front and a recurring 3 and 1. Obviously, if you can answer this sort of question, you should be able to apply the same process to any question that you need to answer. So let's start off as we did before by writing down exactly what this means. So x is equal to 0.5003131 and so on. As before, we need to write two new equivalent equations that have the recurring part appear after the decimal point. Firstly, if I times this equation by 1000, I'm going to get 1000x, which is equal to 500.3131 and so on. If I times the original equation by 100,000, I'd get 100,000x, and that would be equal to 50,031.3131 and so on. As before, all the recurring parts that appear after the decimal place align up, so if you subtract, they'll all cancel out. So let's have a go at doing this. I know that all of my recurring parts are going to cancel out, and if I do 50,031 take away 500, I'd get 49,531. I also know if I have 100,000x and I take 1,000x away, I'm going to be left with 99,000x. So my equation is 99,000x is equal to 49,531. I can then solve this by dividing both sides by 99,000. So therefore x is equal to 49,531 over 99,000. Thankfully for us, this fraction is in its simplest form. However, if you can, it's always good practice to try and simplify it. That means that 0.50031 recurring, that's a fixed 500 and a recurring 31, can be written as 49,531 over 99,000 as a fraction. So what I'd like you to do is complete the task called Recurring Decimals 2, which has been set for you on My Maths. Remember that the first login is always the school login, that's Uppingham and Acute, and then you need to log into your portal using your details which are attached to Show My Homework in the Resources to Help You section. As always, you should aim to get at least 70% on this task to demonstrate that you've fully understood it. If you do need to redo a task and it's disappeared from your homework list, you should be able to find it on the Results tab, which is on the left side when you log into your portal. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.